everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Our topic is Fourier Cosine Transform. This lecture in detail we are going to discuss about Fourier Cosine Integral Formula, Fourier Cosine Transform, and we are going to solve few problems based on Fourier Cosine Transform. The Fourier cosine integral formula is f of x equal to 2 by pi integral 0 to infinity cos px integral 0 to infinity f of t cos pt dt dp. This is the complete, the one is Fourier cosine integral formula. We named it as equation 1. This, from which we are getting Fourier cosine transform. The Fourier cosine transform, that is capital F, which denotes Fourier transform. If it is only f, we will call Fourier transform. If it is fc, then Fourier cosine transform of the function f of x. We can write in this notation, that is fc of f of x. Otherwise, fc of p is nothing but integral, that is the function what is given in the problem. It is a theory, that is a formula, that is the reason f of x into cos px. If it is Fourier cosine, here f of x into cos px dx. In case if it is Fourier sine, then f of x into sine px dx we will be writing. So the integration is done with respect to x from 0 to infinity. So next, here we are noticing this f of x, it is coming out, which is equal to 2 by pi integral the Fourier cosine, which is going inside the integral. The function is coming out. The Fourier cosine is, we are doing the integral into cos px dp. And the integral with respect to p we are doing from 0 to infinity. This is Fourier cosine transform. This is Fourier inverse Fourier cosine transform. The difference, easily, the Fourier cosine transform is with respect to x we will integrate, whereas inverse Fourier cosine transform we will do the integration with respect to p. This is important, the difference we have to remember. Now, the function fc of p, which is a defined infinite Fourier cosine transform. The infinite Fourier cosine transform, why it is infinite? The reason is the limit is infinity. That is the reason it is infinite Fourier cosine transform. Now, so infinite Fourier cosine transform of f of x, where x lies between 0 and infinity. That is only it is written integral from 0 to infinity. And the function f of x is called inverse Fourier cosine transform of fc of p. So this slide, which gives a very clear picture, capital FC, that is Fourier cosine transform. If it is f of x into cos px dx, the function is multiplied by cos px, then Fourier cosine. Whereas the function is out the Fourier into cos px, then it is inverse Fourier cosine. So the Fourier cosine transform formula, we got it, fc of f of x equal to fc of p, which is nothing but the function which is multiplied by cos px, and we will integrate with respect to x, range from 0 to infinity. So inverse Fourier cosine transform, it's very clear. So we should not forget the integral before 2 by pi, and Fourier cosine of the function, what we found the Fourier cosine will be written inside the integral into cos px, integrate with respect to p, then it is inverse Fourier cosine transform formula. So the problem is find Fourier cosine transform of 2 into e power minus 5x plus 5 into e power minus 2x. So the Fourier cosine transform formula, which is written here, fc of f of x equal to fc of p equal to integral f of x into cos px dx. Now our f of x, according to our problem, that is, this is the function which is given in our problem, that is 2 into e power minus 5x plus 5 into e power minus 2x, which is given. So this f of x will be replaced by this given function. Yes, we completely replaced that f of x by 2 into e power minus 5x plus 5 into e power minus 2x into cos px dx. The next one, the 2, we put it up, that is the front of the integral, 0 to infinity, e power minus 5x into cos px dx, that is this term into this one, that is our first integral. Second one, this term into cos px, that is our second integral. In that the 5, the number before the integral we kept. So this is the last step in the previous slide. It is written. Now this integral we have to do it. We are noticing e power minus 5x, that is exponential function. Cos px, trigonometric function. So this both the combination we have to do the integral. How to do? The formula which is available, e power ax cos bx dx, which is equal to e power ax by a square plus b square into a cos bx plus b sin bx. This is the formula. In the formula, a and b both are there. But our given problem, a place minus 5 is there, b place p is there. So that first our formula which should be compared with our problem integration. We did the comparison and a equal to minus 5, b equal to p. This we noticed it. So that we are seeing here, this is the First integral, the solution, that is 2 into, this 2 is kept as it is. The 2 is kept as it is. E power ax. Our a is minus 5. Our a is minus 5. A square, that is minus 5 the whole square, equal to 25. Our b is p square. Here a cos bx, that is minus 5 cos px, plus is as it is. Our b is p. Sin bx, according to our problem, it is sin px, 0 to infinity. So the first integral we completed applying this formula, comparison doing what is our a and b. According to that, completely we finished the first integral. Now we will move to the second integral. The second integral is the minus 5 is written as it is. E power ax. Here the second integral, the a is minus 2. That a value is minus 2. B is p. So e power minus ax, it's nothing but e power minus 2x divided by a square, p square. Here a cos bx. What is our a? Minus 2. So a cos bx. Bx is what? Px. Plus b sin bx. Here our b is what? P. That is according to our problem, b is p. So that we substituted. We replaced it. That is in the p place. According to our problem, what is b? In the particular position is p. So in the formula, we put it p. Now we have to apply the limit. Upper one is infinity. The lower one is 0. Now, which place we have to? P or x? Compulsory with in the place of x we have to put it. The reason is we did the integration with respect to x. So x place we are keeping. The first one is e power minus infinity. Here e power minus infinity. E power minus infinity, the value is 0. We have to. E power 0 means the value is 1. Now, so the upper one, e power minus infinity, the upper one is vanished. It is 0. Minus, formula minus. So the down one is what? 0. That is e power 0. E power 0, the value is 1, we know it. So 1 by 25 plus p square. Here we are substituting minus 5. Cos 0 value is 1. Then here we are substituting p into sin 0. Sin 0, the value is 0. So minus 5 by 25 by plus p square. So we substituted that 0 to infinity. That work also completely over for the first integral. Now we will move to the second one. This plus 5, it is written as it is. E power x place we are substituting. E power minus infinity is 0. So completely it has become 0. And minus, formula minus. The down part is 0. That is e power 0. So e power 0, we will substitute here. 1 by 4 plus p square. So here we are substituting minus 2 into 1 plus p into 0. P into 0. So now we can see it. 0. Formula sign. So minus 2 by 4 plus p square. Yeah, fine. Now this minus, it has become plus. 2 5s are 10. This minus, it has become plus. 5 2s are 10. So we completed this problem. The next problem, find the Fourier cosine transform of this particular e power minus ax minus e power minus bx by x. This is the function we have to find Fourier cosine transform. So first we are writing the Fourier cosine transform formula. So we know it now. We are very familiar with the Fourier cosine transform formula, that is FC, Fourier cosine transform of the function f of x equal to that f of x is multiplied by cos px dx. We will do the integration with respect to x from 0 to infinity. Now, our f of x, they are telling the completely, this is the function which is given. First, instead of doing this e power minus ax, this can be written as e power minus ax by x minus e power minus bx by, we can expand and we can write it. That is the question which is given. In such a way we can write it. Now what we are going to do, this part only we are going to target now. We are not taking the complete one as f of x. Some part, the part of our question, e power minus ax by x, f of x we are taking. First we will solve it. What we are going to get the result, we will see it. Okay, fine. Now, differentiating both the sides with respect to p. Now this left side is capital FC of f of x. We know it, differentiation is dy by dx. This is the formula. So d of this divided by dp. Why we have to do with the p? To bring actually the result only. Because actually the integration is with respect to x, that Fourier cosine transform formula. But this we have to solve. Our aim is, this we have to do integral. The comfortable also we want it. Our convenient also we want it on the basis of easy to integrate. So on the basis easy to integrate, this x is troubling us. Better we can remove that x. In what way we can? Both the sides we will do with respect to p. Yes, we did the left side with respect to p. Coming to the point, the right side. Now, this is there. E power minus ax by x. Because we are doing the integration, we are doing this differentiation with respect to p. This part, there is no p term at all. So we are not at all touching that part. Whereas coming here, cos px is there. Cos differentiation is minus sine. So minus sine px. Again with respect to p, we should do it. If we do p, total is px. P we are doing. The left is the coefficient x. Easy actually the integration is cos px. Cos of some term. minus sign of some term. The sum term is nothing but our px. In the px, we wanted coefficient of p. Why we are stressing the coefficient of p? Because we are concentrating everything differentiation with respect to p. The coefficient of p means leave a p. The leftover is what? X. So that only into x. Now this x, it is getting cancelled. That part only it is written here. This minus sign only here. X e power x sin px dx. X and x getting cancelled. The balance one, the remaining part we got it here. The minus is kept before the integral. Now this part, now integral, it is very easy and convenient to us. But if this x is there, it is difficult. Now e power minus ax into sin px dx. One is exponential, another one is a trigonometric function. Formula which is available. That is, this is the formula e power ax sin bx dx, which is equal to e power ax by a square plus b square into a sin bx minus b cos bx. This is the formula. Now this formula should be compared with our problem. If we do comparison, we are getting here in the formula A, whereas in our problem minus A is dominating. In the formula B, but our problem P is dominating. So according to that, we have to do it now. So that minus sign as it is, we are not disturbing at all. That minus sign, we kept it as it is. Here, e power ax. But our problem, minus a. So that is the reason e power ax by a square plus b square, a sin bx minus b cos bx. This is only our formula. So the a, which is replaced by minus a square as it is, that is minus a the whole square. It's nothing but a square. Our b is nothing but p. So p square. A is replaced by minus a. Sin bx, it's nothing but sin px minus b. B is nothing but p. Cos bx. So cos px. The two things we have to keep in our mind. What is A? What is B? These both are, what is the role they are playing in our problem integration. That we have to notice it first and easily we can apply it. So we applied it. This minus sign, it is kept as it is. E power minus infinity. It's nothing but the value is 0, we know it. E power 0, the value is 1. So the upper one, e power minus infinity, x place we are substituting because we did the integration with respect to x. So the completely the upper one is getting vanished. This is the formula minus. So the lower part we are going to touch, that is 0. So e power 0, the value is 1. So 1 by a square plus b square. So minus a into 0. That is sin 0 value, we know it, 0. Minus p. Cos 0 value is 1 into 1. So here, so minus p by a square plus b square. This minus, it has become plus. Already the outside one minus is that it is written as it is. So minus p by a square plus b square, we got it. Now integrating with respect to p. This what is the result? We got it that we are going to do integration. So the left side, the integral. This what we just now we got the result that we did the integration with respect to p. Here, if you're noticing the left side, integral and differentiation, both are getting cancelled. So the Fourier cosine transform is left. Here, this integral, we are keeping in the mind dp with respect to p we are doing. So the p square, the denominator is there, the p square. If we do the differentiation, 2p we will be getting. But here only p is there. That is the reason. So up, multiply and divide by 2 we are doing to make the integration very comfortable way to do it. That is the purpose. Multiply and divide by 2 we are doing. So the left side, the Fourier cosine of the function f of x equal to, so this is the last one we got it. This is the integral, we can write it, minus 1 by 2 log of, there is a rule, that is here the down, the denominator, if the differentiation is dominated in the numerator, we can write log of a square plus b square. For that purpose only multiply and divide by 2 we did. So we got it, the integration minus 1 by 2 log of b square plus a square plus c, the constant we neglected it. Yeah. So now the Fourier cosine, the transform of the function f of x, we got, this is the result. We have taken the function e power minus ax by x. But our question is e power minus ax minus e power minus bx by x. This is only our question. They asked us to do Fourier cosine transform for this. But what we did e power minus ax by x minus e power minus bx by x. Only this, a part of our question only we did. And e power minus ax by x, the result we got it minus 1 by 2 log of p square plus a square. So we are not going to do this second part at all. Looking at this, what we solved, the part of our question, similarly putting, we can write it. That is, if it is e power ax by x, we got it minus 1 by 2 log of p square plus a square. Very simple logic. That is, if it is e power minus bx by x, the answer will be minus 1 by 2 log of p square plus b square. So the question it is written, Fourier cosine transform of e power minus ax minus e power minus bx by x. This is common, x is the common LCM. So we separate, we wrote that as the one function, it is written as two functions. So the first one which is substituted here, So what we got it here, this place it is substituted here. For this it is substituted. Some modifications we did. That is here in this both the terms 1 by 2 is common. We have taken out. This positive part first we wrote it. This is written in as second because we know it log A minus log B can be written as the logarithmic formula log of A by B. That we are going to use. So it is written 1 by 2 log of P square plus B square divided by P square plus A square using the logarithmic formula log A minus log B. It's nothing but log of A by B. So we will concentrate one more problem. Find Fourier cosine transform of the function f of x equal to e power minus ax cos ax. The solution we will do it. So the given function is f of x equal to e power minus ax cos ax. The Fourier cosine transform formula is fc of f of x equal to fc of p equal to, that is the f of x, which is multiplied by cos px and integration with respect to x from 0 to infinity. So now the f of x, which is replaced by the question what is given, f of x equal to e power minus ax into cos ax, we replaced it. So now we are noticing the integral we have to do it. One exponential, two trigonometric functions are there, cos ax, cos px. If any two trigonometric functions, if it comes, then corresponding the formulas we have to take. Now, 2 cos A cos B, it's nothing but cos of A plus B plus cos of A minus B. So we will do the comparison with our A and B. Our A is AX, our B is PX. So we are going to substitute in the place of A, AX, in the place of B, PX we are going to substitute. Yes, now this part it is there. So the cos 2 cos AX cos PX. Here the 2 is not there. So we are bringing to the right side. That is the reason it has become here 1 by 2 cos of A. A is nothing but AX plus PX plus cos of AX minus PX. So we will see it. This 2 has become here. Here we can notice it. Then the e power minus ax is written as it is. Cos of ax plus px. X is common. That is the reason here it is written cos of a plus p of x plus, this is two terms. First term, second term. 1 by 2 is common. So the second one, e power minus ax. Here also we are noticing x is common. So cos of a minus p, here x should be there. A minus p of x dx. So one is exponential, another one is trigonometric. So one exponential, one trigonometry, the formula which is available. That formula we have taken. So e power ax cos bx dx, we know it very well. E power ax by a square plus b square into a cos bx plus b sin bx. We will do comparison with our problem, and we noticed it in the formula a means our problem is minus a, and if it is b, then ours is a plus p. A equal to our problem minus a, and b is playing the role a plus b. So in this a plus minus a, b plus a plus b, that keeping in our mind, we will do the integration. That is the first one, we will do it now. So the first integral is 1 by 2 e power ax, but according to our problem, e power minus ax, a square, that is minus a the whole square is a square. Here actually b square according to the problem, sorry, according to the formula, but according to our problem, it is a plus p. So a plus p the whole square. Here a into cos bx, so minus a into cos of bx. So bx, our b is, we know it, a plus p, fine, plus b, a plus p, sin bx. Our problem b is a plus p, so a plus p x. So completely the first integral, we finished it, 0 to infinity. The next integral we will move. So when we are noticing the second integral, the problem a is dominated by minus a, b is dominated by a minus p. Yeah, we can see it, the second integral. This 1 by 2, here it is there, it is written e power minus ax, a square, b square, it's nothing but our a minus p, so b square, a cos bx minus a, that is ours is minus a, cos bx, our b is a minus p, same the plus formula plus, here also plus, b, it's nothing but a minus p, sin of b, a minus p, x, 0 to infinity. Now we substituted. So here first one we will substitute. So e power minus infinity equal to 0, e power 0 equal to 1. According to that, the upper one, x place we are substituting because we integrated with respect to x. So the upper one is 0. Completely it is vanished. Minus formula e power 0, that is 1 by a square plus a plus p the whole square into minus a. Because we know it, cos 0 means 1. This part it is becoming 0. The reason is sin 0, the value is 0. So here minus into minus plus a by a square plus a plus p the whole square, we got it for the first integral. Coming to the second integral, e power minus infinity, the upper one is 0, formula minus, then e power 0, 1 by a square plus a minus p the whole square here minus a, because minus a into cos 0 the value is 1, whereas plus this part is becoming 0 because sin 0 the value is 0. Here we got it minus into minus plus a by a square plus a minus p the whole square, we got it. That's what it is written here. The next step, so we know it, minus minus plus. Here also minus minus plus. This term and this term, the common is this 1 by 2, and not only 1 by 2, a is also common. That's what a by 2 it is written out. So if a completely coming out, the remaining is 1 by this part, the numerator, it is written as it is. Here also the numerator, it is, denominator. So a square plus a plus b the whole square, the denominator it is written as it is. Here also the denominator it is written as it is. Yeah. Now this a by 2 it is written here, and we are doing the LCM, that is cross multiplication it has taken. You can notice it here. So this term up to here it is there. This term here it is there. Just we have taken the LCM. The next step, this part a square, this we are applying a plus b the whole square, a square plus 2ab, that is our b is p, plus p square. This a square, it has become 2a square. That is the reason it is written here. Here also the same thing, a square minus 2ap plus p square. This a square, it has become 2a square. This is only the, we are applying that a plus b the whole square and a minus b the whole square formula we applied, and we did the simplification. And here a square, this is a minus b the whole square formula we applied, a square plus p square minus 2ap. Here this a square, here a plus p the whole square, a square p square plus 2ab. We are noticing few terms are getting cancelled. This term, it is getting cancelled. A square we counted 1, 2, 3, 4, 4a square, p square 1, 2. So 2p square. The down part, this we know it. This is 2a square plus p square plus 2ap. That is, we wrote it 2a square plus p square the whole square. That is, here we did the simplification. What simplification is done here? This part we have taken as one term. Both are same. We know the formula. A plus b into a minus b can be written as a square minus b square. It is a basic formula, algebraic formula. We studied in lower classes, that we applied it here. That is, this part is common. So that is completely, this is has square, and this part a plus b. If you notice, a simple way to understand, this is a, this is a. So a square, this formula minus b square. This term we are assuming as b, so it is b square. So we have taken help from this algebraic formula for the simplification. So now in this, here 4 is there, here 2 is there. So we have taken the 2 outside. The 2 getting cancelled from here. This term, 2 we pick it out. So 2 And already here the 2 is there, both are getting cancelled. So the a is left over. The 2 it has gone out. So a square, 2a square plus b square. Yeah, we will come to a conclusion that Fourier cosine, the transform formula, easy way, the notation, capital F represents Fourier transform. If it is capital FC, Fourier cosine transform. If it is FC of f of x, we will read Fourier cosine transform of the function f of x. Otherwise, FC of p, that is the integral we have to do the given function into cos px and integrate with respect to x from 0 to infinity. We detail this video lecture we discussed and we did the problems, that is the Fourier cosine transform of 2 into e power minus 5x plus 5 into e power minus 2x. This problem we solved it. And the next one we have taken, that is a big function e power minus ax minus e power minus bx by x. We didn't concentrate, we didn't do Fourier transform 2 times, only 1 time we did. From the 1 time applying the Fourier cosine transform, we did the analyzing. Similarly, we have done it for this other part of the function. We did and we got this result also. And one more problem, that is e power minus ax into cos ax. Here we applied the trigonometric formula, that is if any 2 trigonometric functions they are dominating, then we applied the corresponding trigonometric formula. How to solve, that is also we discussed in detail. Throughout this video lecture, this Fourier cosine transform, this formula is dominated in detail how to apply the formula e power ax by a square plus b square into a into cos bx plus b into sin bx. And we did a comparison with our problem integration. What is a, what is b? We did and we solved it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.